Good evening, everyone. Myself Gautam Sarma. I welcome you all in Sapience Education. So today I am going to discuss about the chapter atom. Okay, so I hope you will have understood this chapter. Uh, First of all, we will discuss about the Rutherford uh, model, drawbacks of the model. As we have earlier, we have studied about the Rutherford model, but Rutherford model has suffered two major drawbacks. So first of all, regarding the stability of the atom. What is the stability of atom? Now, first of all, think like this that electron revolve around the nucleus. So let us consider this is the nucleus part and electron is revolving around the nucleus, right? Now, according to classical electromagnetic theory, the electron must radiate energy in the form of electromagnetic wave. Why? Because it is whenever it is moving, it must radiate energy, and whenever it should radiate the energy means what means it means that it should must radiate the energy, and due to the continuous loss of the energy, what will happen? What will happen? It will try to come closer to the nucleus, and finally, what will happen? It will get collapsed. So from this theory, from Rutherford's theory, any of the atom will become unstable and it won't exist. So this is not what's possible. Practically, it is not possible. So again, next loophole that Rutherford has done regarding the explanation of the line of the X spectrum. Due to continuous decrease in the radii electron of the orbit, the frequency of revolution of electron will also change. And according to classical theory of the electromagnetism, frequency of the electromagnetic wave emitted by the electron is equal to the frequency of the revolution. But due to continuous change in the frequency of revolution of electron, it will radiate electromagnetic wave. All the frequencies, that is the spectrum of this wave, will be continuous in a nature, but this is not the case. The thing is that let us consider again, I'm talking about the electrons are outside the nucleus. So this is nucleus. So what will happen if electron is moving? So what will happen? It will radiate some of the energy, and when it will radiate some of energy, it means electron will lose energy, and when electron will lose energy, it will come more closer to this. So it means that slowly it will radiate the energy, and slowly you will get the energy wave, and this wave will have a certain spectrum or a frequency. So it means that we should get the continuous wave or continuous spectrum, continuous spectrum, right? Continuous spectrum, let us consider this is a spectrum. So this should be wholly continuous, but what happens actually, it is not continuous. We are getting, it is not continuous, it is discrete, right? So how this is possible? So here also Rutherford has failed to explain. Now next, Bohr has come to rectify this. So Bohr's model of the hydrogen atom. So he has explained it with the help of hydrogen atoms. So Bohr combined classical and early quantum concept and gave this theory in the form of three postulates. Bohr has given a three postulate. So Bohr's first postulate was that an electron in an atom could revolve in a certain stable orbit. It means that as per the Bohr's, if this is a nucleus, that is neutron and proton is present in the nucleus, so electron should only move in a certain orbit, certain discrete orbit. Okay, it should not be like this. It should not be like this. Electron should move like this, like this, like this. It should not happen, right? So it means that electrons should always move in a certain fixed orbit without emission of radiant energy. It means that electron is not emitting any type of energy while in a revolution. And according to this postulate, each atom has certain definite stable states in which it can exist, and each possible state has a definite total energy. So if electron is moving in this orbit, so it has some definite total energy, and this is called the stationary state of the atom. So in this atom, in this state, what happen? Electron will move in a fixed orbit, and the whole atom is considered as the stationary atom, right? Now next is Bohr's second postulate. Now, as per this, it states that the electron revolves around the nucleus only in those orbits for which the angular momentum of is integral multiple of h by 2 pi. So let us consider this is a neutron as well as proton, and there is an outermost orbit, orbit A, maybe orbit B, maybe orbit C, it may be orbit D, like this. Okay, so what happens? 1, 2, second orbit, third orbit, fourth orbit, fifth orbit, like this. Now, as per the Bohr's, electrons should only be revolved around the nth orbit or any orbit which have angular momentum is equal to the integral multiple of h by 2 pi, where n is equal to 1, n is equal to 2, like this. If it is not integral multiple then of the h by 2 pi, then electron cannot be stable. Let us consider electron is here, electron is here, electron is here, but electron does not exist in 1 and 2. Why? It may be that this at this orbit or at this orbit the angular momentum is not the multiple of integral multiple of h by 2 pi, and it means that this does not exist. So what we have learned from previous one, that electron will move in a fixed or fixed fixed orbit. Now second one is that in each orbit in which electron is moving should be the integral multiple of h by 2 pi. So I hope you have understood this. Now next one is angular momentum of electron can also be considered as MBR. Why it is considered as a MBR? Let us suppose this is a neutron, proton, and this is an outermost orbit, and this is R, and mass of electron is m, and it is moving with the speed, and v is the velocity. Now angular momentum, that is p is equal to mv into r. Now for any permitted stationary orbit, MVR should be, now what we have done, we have studied that the angular momentum for a stable condition, angular momentum should be of equal to nh by 2 pi, right? And this should be equal to MVR as per the Bohr postulate, right? Now from here we can get some equation that MVR is equal to nh by 2 pi. So from here you can get any value, any unknown value, that is r. You may get r is equal to nh by 2 pi mv, 2 pi mv, like this. So this is the way you can proceed. Now next is your Bohr's third postulate. Now Bohr's third postulate, and it states that an electron might make a transition from one of its specified non-radiating orbit to another is lower energy. Now let us consider we have let us suppose this is your neutron and proton, and this is an orbit, fixed stable orbit in which there is no radiation of the energy, and this is second orbit where there is no radiation of the energy. Now let us consider if this the energy level of this orbit is ei, and energy level of this one is ef final, and this is your initial one. Now as per this, whenever electron will jump from initial orbit to final orbit, so what will happen? Let us consider if it will jump. Now see, earlier what happened, electron was revolving around this with a certain fixed amount of energy, and it is stable and it is not radiating any type of energy. It is not radiating. This electron as well as the electron in this orbit will not radiate any amount of energy. Now as soon as if anyhow by losing electron, it will jump to this directly. So let us consider EI is the initial energy and EF is the final energy. So what will happen? It will radiate, see, whenever it will jump from higher to lower orbit, so what will happen? It will generate electromagnetic wave, and electromagnetic wave, EMW, and this wave will have a certain energy, and this wave have a certain energy, and it is equal to h nu, and h nu will be equal to initial energy minus final energy, where initial energy is greater than the final energy. So this is the way how we can find the frequency of the radiated wave. Now next one is Bohr's theory. Now Bohr's model is valid for all the one electron atom and ions, which is consist of the tiny positively charged nucleus and electron revolving in a stable circular orbit. And this one electron atoms or an ion is called as hydrogen like atom. So you can also call as He plus or Li 2 plus as same hydrogen atom, right? So I hope you have understood this. Now let us consider E is the electron, M is the mass of the electron, and B is the velocity of the electron, respectively. And the charge, mass, and velocity of the electron, and R be the radius of the orbit. The positive charge on the nucleus, that is Ze, where Z is the atomic number, as the centripetal force is provided by the electrostatic force of attraction. So we can say that. Now see, try to understand. There is a nucleus in which you will get neutron and proton, and outermost orbit will have an electron which is being revolving around it. Now let us consider this orbit has a radius r, and the mass, it has a mass of the electron is m. So now tell me, if it is revolving around it, so it has some kinetic energy. So we can say that kinetic energy or the energy, we cannot say kinetic energy, we can say centripetal force. Why? Because there is a some force which is being acting around the electron, so that it can revolve around it. Now what we can say? We can say that the centripetal force can be written as mv square by r. But the thing is that who is the, which type of force is providing this centripetal force? We know that the electron is being revolving around the circular path due to the centripetal force. But who is that force? Which type of force is acting upon it so that it is revolving around it? So definitely electrostatic force will be have a electrostatic force or electrostatic force. So electrostatic force will be have a formula K Q1 Q2 by R square, but here K is same, that is 1 by 4 by epsilon naught, and charge is your Ze, where Z is the atomic number and E is the charge of the proton into E. So again, so K has a some value, that is 1 by 4 by epsilon naught, and this is your R square. So finally what we have got, that mv square by r is equal to k ze square divided by r square. So r square got cancelled out. From this we have got mv r is equal to n h by 2 pi. So this is the very important derivation. From here we have got this mvr is equal to nh by 2 pi. Now let us think about this. When n is equal to 1 to 3, it is the principal quantum number, where n is considered as the principal quantum number. So from this equation we can also say that we can get equation 1. So first of all, try to understand what are the equation 1. So definitely this one is the equation 1 and this is equation 2. Now we need to put the values of the r. So from here, why we cannot take r as equal to n h by 2 pi mv. Now put this to this place, so what we will get? Now if we will put this place, so finally you can get it as like this. So what you need to do? So first of all, you need to write mvr is equal to nh by 2 pi. So let us write mvr is equal to mvr is equal to nh by 2 pi. Now r can be written as nh by 2 pi mv, 2 pi mv. Now mv, and here it is mv square. So mv, in place of mv we need to put the value. See here, they have written mv square is equal to z is square. Let us mv square is equal to ze square. mv square is equal to z square by 4 pi epsilon naught r divided by 4 pi epsilon naught into r. Now we need to put the value, so that we need to put the values, right? So ultimately what we need to put the values, mb. Okay, now just take it like this. If we put the values like mb is equal to z square by 4 pi epsilon naught r into v. Okay, now we can put this mb here. Now from here, we have got, so let us again rewrite the equations. Now from here what we can write, mb square is equal to z square. So from here we can write m square b square is equal to m z square by 4 pi epsilon naught r. Also from here we can write mb is equal to nh by 2 pi r. So from here we can also write mb whole square as n square h square divided by 2 pi, means 4 pi square into r. So we can equate this both. So because it is your also mb is m square b square, and this is also m square b square. So what we will get as mze square divided by 4 pi epsilon naught r is equal to n square h square divided by 4 pi square into r square. It will be r square. From here we have got this as cancelled. From here what we have got, r is equal to, r will be equal to, if you rearrange this equation, so you will get n square h square epsilon naught divided by pi m z square. Now whatever these values are, all are constant only, constant. So from here what we can say, that Rn is proportional to the n square, that is number of the orbit. Okay, so here we have got the equation. So according to this equation, radius of the permitted orbit is, according to the equation, Rn is equal to n square, where n is equal to 1 2 3 dot 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 dot. It will be 1 4 9 16. So if the number of orbit is 1 2 3, so the radius will be in the ratio of the orbit 1 is to 4 is to 9. So I hope you all have understood this. Now one thing we have that the what is Bohr's radius? The radius of the first orbit, that is n is equal to 1, of a hydrogen atom, z is equal to 1, will be how much? Now we have got the formula, r is equal to n square. We have got the formula. Let us go for the general formula first of all, that is r n is equal to n square n square h square epsilon naught divided by pi m z e square. Now for Bohr radius, if they are considering n is equal to 1 and z is also equal to 1 because of the hydrogen atom, so what we can say that Rn will be equal to h square epsilon naught divided by pi into m e square, right? Now this is called the Bohr radius and its values is how much? So when you will put the values, so here we will get as 0.53 angstrom, right? Since r is square times of the n, so from here r is proportional to the n square, so the radius of the second orbit will be how much? So definitely it will be 4 times, right? Why? Because Rn R1 is equal to see, R1 is equal to 0.53 angstrom. So R2 will be how much? Since R is proportional to the square times of the n, so it will be 2 to the 4. So it will be 4 times of the 0.534 angstrom. And again, if you talk about R3, so it will be 3 square times of the 0.53 angstrom. Like this, we can go, right? So I hope you have understood this equation. Now let us talk about the velocity. Velocity. Now the electron, we can obtain the formula from the velocity electron is permitted orbit. We have V is equal to nh by 2 pi mr, right? So from here what we can got, see again I'm telling you from where I'm getting this one. So we have mbr is equal to nh by 2 pi. Now from here from here we have v is equal to nh by 2 pi into mr. Now we have got the values of r, so we can put this nh by 2 pi into m into, it will be, r has a formula n square h square epsilon naught divided by pi mz e square. Now if you will rearrange and do this, so we will get at z is square divided by 2h epsilon naught into 1 by n. So from here what we have got, velocity is proportional to 1 by n. So this is one of the important conclusion. We have got it. So since n, again I'm telling you, n is our principal quantum number, so v is inversely directly proportional to 1 by n. So this shows that the velocity of the electron is maximum in the lowest orbit and goes on decreasing. So at lowest orbit, so n is equal to 1. So since it is your inversely proportional, so as soon as the value of n will increase, so what will happen? Velocity of the electron moving around the orbit will decrease, right? I hope you have understood this. Now you can observe from here that v1 is equal to e square by 2 h epsilon naught. So we can put here c by 137. Why c by 137? C is the speed of the light, and right, speed of the light. Now we will go about the frequency, right? Now you are thinking that why I am writing it as a c is equal to 1 by 37. So they have given the value in such a way that v becomes c by 137 only. Now we will talk about the frequency of the electron or stationary orbit. So let us consider this is the orbit, this is neutron pattern, and this is radius. That is the number of revolution completed per second by the electron in a stationary orbit, the nucleus. It is represented by v. Now let us consider V is equal to R omega, right? V is, if it is moving with the velocity v, and omega is the angular velocity, then we can represent it like this only. Now we know that omega is equal to 2 pi by t, or 2 pi by t, or we can write here 2 pi into frequency. I'm not talking about the velocity. So we can write it in a proper way, that the velocity is equal to r into 2 r into r into 2 pi 2 pi nu, right? Now from here frequency will be equal to, sorry, v will be equal to v will be equal to um, not v exactly, so it will be frequency only, right? So frequency, from here what do we need to find? Frequency. So let us consider we need to find a frequency. So frequency will be equal to v by 2 pi r, v by 2 pi r, right? Putting the values of v and r in the above equation. So if we put the values of v and r in above equation, so what we will get? One I will get as 2 pi 1 by 2 pi r into z e square by 2 h epsilon naught into 1 by n, right? So finally we have got as frequency as 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught z e square by n h r. Again, 1 by 4 pi epsilon naught is considered as a k in electrostatics. So this will be k into z e square divided by n h r. So finally we have got this equation for the frequency, and so we have got the equation of the frequency, right? Now let us consider now energy. We will look into the matter about the energy. So energy of the electron in a stationary orbit. So E is the energy of the electron in an orbit, and the sum of the kinetic and potential energy. So using this force theory, mv square is equal to z square by 4 pi epsilon naught into r. We have already done this. Now what is the formula for the kinetic energy? If you it would have a kinetic energy is equal to half mv square. Now we have mv square, so we can write, so from the above equation we can write as z e square by 8 pi epsilon naught ry, because it is 4 pi, and when I will divide it by 1 by 2, so it will become 8 pi. So finally we have got kinetic energy, right? Now when again we need to substitute the value of r, so while you will substitute, so try to do it by yourself. So it will become as mz is square e to the power 4 by 8 epsilon naught square into h square into 1 by n square. So this is only variable and this all are constant. Now putting this, since we can also take as r is equal to m e to the power 4 divided by 8 epsilon naught square ch cube. If we will took this, so what we will get? We will get as a rhc by n square, right? So this is the kinetic energy. Now when we talk about the potential energy, so potential energy as per the electrostatic uh, theorem, so potential energy will be equal to, potential energy will be equal to k, that is 1 by 4 pi epsilon naught into q1, that is ze, into charge q2, that is minus e, divided by r. So finally we have got 1 by 4 pi epsilon naught into z e square by r, right? So this is the potential energy. I hope you have understood this. So we have, when we talk when we get this in terms of r, so we will get at just to put it, so potential energy will be equal to minus 2 r h c divided by n square Now we need to calculate total energy. So when we talk about the total energy, so this will be potential energy plus kinetic energy. So that is equal to Z E square by 8 pi epsilon naught into R minus Z E square divided by 4 pi epsilon naught into R. So when we calculate it, so finally we will get a Z square by 8 pi epsilon naught into R. So this is minus RHC, that is RHC divided by N square. Now substituting all the values R substituting values of R, we will again get RHC. If you put in original form, so what we will get as, why original form? Because we have considered this as R as m e to the power 4 by 8 epsilon naught square into CH cube. Now when we put it, so what we will get? Now let us see, E is equal to minus m z square e to the power 4 divided by 8 epsilon naught square into h square into 1 by n square. Now finally, if you calculate this, so what we will get? Total all are constant terms. So when we calculate this, so you will get at minus 13.6 by n square electron volt. So this is the energy, right? This is the energy for the nth orbit. This is the energy for the nth orbit. Nth means n is equal to v for the nth orbit, right? Now, if since En is equal to minus 13.6 minus 13.6, let us see here. It is minus 13.6 divided by n square electron volt. So this is the energy. So you may get energy level for the first orbit, you may get energy level for the second orbit, you may get energy level at the third orbit, right? So these are the energy level, and at the different energy level, electron will reside from here to here. There will be an electron, there will be maybe an electron, this energy level may be electron, but in between you won't find any electron in transitions, because electron will always be in that orbit which has a which is the multiple, which has the angular momentum having a multiples of n h by 2 nh by 2 pi. So it is must be the multiple of the angular momentum of the n. So we have got this. Now see here, the energy of an atom is the least when its electron is revolving in an orbit closest to the nucleus, and it is your negative, right? Now as soon as we go on, so energy will increase. As soon as you will go on from starting this center toward outside, so what will happen? As soon as the radius will increase and number of orbit will increase, so what will happen? Energy will increase, and the lowest state of the atom is called the ground state. In ground state, so energy will have maximum values. So ground state means this state where n is equal to 1. So therefore the minimum energy required to free the electron from the ground state of the hydrogen atom is minus 13.6, and it is called then ionization energy. So ground level means stable level. So in an stable level, so the minimum amount of energy required for the for the excitation of the energy. Let us consider this. This is a neutron and proton, and this is electron, and it has a minus 13.6 electron volt as the minimum level of energy. When you give this energy of 13.6 electron volt, so what will happen? It will absorb this energy and it will go out, and this minimum energy required required to free the electron. If you want to make free, see, with the help of this amount of energy, it has been stuck with the neutron and proton, that is the nucleus. When you put 13.6 electron volt of energy, so what will happen? Electron will jump out, and this minimum energy required to make jump it out is considered as the ionization energy of the hydrogen atom. So at a room temperature, most of the hydrogen atom are in a ground state only, and when atoms receive some energy, so by electron or collision, the atom may acquire sufficient energy to raise the electron to a higher energy state. In this condition, the atom is said to be excited state. So in a ground level or at a room temperature, it will be in its own orbit. and in that orbit you required minus the or you required 13.6 electron volt of the energy to free up this space. So I free up this electron from the atom. So I hope you have understood this. Now from here you can also observe that what are the energy. See, as soon as the ground state n is equal to 1, so the energy will be minus 13.6. Why? Because energy En is equal to minus 13.6 divided by n is square. When you put n is equal to 2, you will get an energy of minus 13.3.40. Similarly, minus 0.51, minus 0.81. And one time will come that it will become unbound and this energy will become zero. So these are the energy level. Now let us try to understand that understand that there are two levels of the energy, and this is your E2 level and this is a E1 level, right? So E2 has a formula of mz square e to the power 4 by 8 epsilon naught square h square into n1 square, right? And E1 has a not a n1 square, it will be n2 square, right? And if we talk about the E1, so E1 will be mz square e to the power 4 divided by 8 epsilon naught whole square into h square into n 1 square. Now if you do E2 minus E1, so finally what we will get? We will get same equation, right? That is equal to mz square e to the power 4 divided by 8 epsilon naught into h square into 1 by n square n1 square minus 1 by n2 square, right? Now E2, so E is equal to h nu, so from here we can find nu is equal to E by h. So why not we can calculate it? So when we will calculate nu, that is equal to E2 minus E1 divided by h, and this will be equal to, when I will divide it by h, so what we will get? mz square e to the power 4 divided by 8 epsilon naught into h cube divided by 1 by n is n1 square minus 1 by n2 square, right? So finally we have got this equation. Now you from this see, frequency is equal to frequency, see, E is equal to h nu, and this is equal to hc by lambda, hc by lambda. So h has got cancelled, so frequency can be written as c by lambda, right? So from here what we can take that c by lambda, in place of frequency we can write c by lambda, and this will be equal to, this will be equal to c by lambda, that is c is the velocity, so this will be velocity divided by lambda, and this will be equal to, we can put here in place of frequency we can put c by lambda or b by lambda, and b by lambda, or we can say that 1 by frequency. So from here 1 by frequency, now from this what we can observe that hc hc by hc by lambda is equal to h nu, so h got cancelled out. So from here 1 by lambda can be written as frequency by c. Now from here what we can say that 1 by lambda can also be written as frequency by c. If you divide frequency by c, so this will become as mz square e to the power 4 divided by 8 epsilon naught whole square into ch cube into 1 by n1 square minus 1 by n2 square. So where 1 by lambda is called wave number, so this is considered as the wave number. I hope you have understood this. Now the thing is that we need to understand that the last equation, the quantity m e to the power this is a constant, and it is called Rydberg constant. So from here we can write that m e to the power 4 into epsilon naught r square into chq as r. So we have already considered previously only. So finally we have got as 1 by lambda is equal to z square into r into 1 by n square minus 1 by m2 square. Now for hydrogen atom, now let us generalize the equation. So for hydrogen, what we will get? For hydrogen Z will be equal to 1. So by putting this 1 by lambda will become as 1 by R, or sorry 1 R by N1 square minus N2 square, where N1 and N2 are the number of orbit 1 as well as N2 number of orbit 2 or initial and final orbit. So from here we can find easily the lambda values, right? So this is the way how to get the values. So many things you have learned, I hope, and as well as we have understood how to find out the frequency as well as lambda. Now let us consider the radius of the innermost electron of the orbit of the hydrogen is this. Calculate the radius. See, the radius of the innermost orbit, that is r, they have provided you, right, is 5.3 into 10 to the power minus 11 meter. Calculate its radius. Calculate its radius. So r, that is r1 they have provided you. Then we need to find the radius for n is equal to 1. So r2 they are asking you. So what we need to do? R1 is equal to, they have given us 5.3 into 10 power minus 11. Rn is equal to n square r1. So from here r2 will become as 2 square into this. So we will get the r2, right? Now what they have told me us that total energy of the electron, second part of the question, if you observe it, so you will get that total energy of an electron in the second excited state, total energy in second. So E2 they have provided as minus 1.51 electron volt. Find out its kinetic energy. So kinetic energy is equal to how much, and potential energy is equal to how much. So how we need to proceed it? So see here, as E they have provided you like this. So kinetic energy of electron is equal to negative of the total energy. Why so? We have already derived these things. See, we have derived this thing. See here, you will observe that. See from this equation, these values and these values both are similar only, but only thing is difference like this. So total energy is equal to negative of the kinetic energy. So whatever kinetic energy will be there, it will just put a negative. And potential energy, if you down it, so it will be 2 times of the kinetic energy or total energy, right? So we will use this method to find out the problems, right? So try to solve it. See, so since we have got kinetic energy as equal to minus negative of total energy, and this will be equal to 1.51 electron volt, and potential energy will be always 2 times of the kinetic energy, but it will be with the negative signs. Always remember, potential energy will be of this type of orbital energy. Potential energy of an electron can be written as negative only. So we can put here the values. So we are getting the values as minus 3.02 electron volt. So these are the easiest questions. So they will ask you on the formula based question will be asked in your exam, right? Formula based question will be asked. Okay. So I hope you have understood this. So in from next class I will teach hydrogen spectrum. So try to be part of that class. Thank you for watching my video.